Plant Power Distribution Systems, LNG plant. Hello, my name is James Bong. I have been working at Korea Gas Corporation for 21 years, such as electrical equipment repair and maintenance team in Pyeongtaek and Incheon LNG terminal, and LNG terminal improvement team, and electrical engineering team of LNG terminal division. Currently, I'm a senior manager in electrical engineering team of LNG terminal division, and I'm responsible for design and engineering electric equipment and substations in KOGAS LNG terminals. I made this presentation for KOGAS workers in-house training course. I think this subject is so important to electric engineers who are responsible for designing electric equipment at oil and gas plants or LNG plants. I'm not an excellent engineer who understands all theory of electricity, but I want to share some electrical information that I studied and understood with KOGAS workers and someone who wants to understand LNG plants' electric power distribution systems. This paper is based upon the premise that the plants are using IED and electric power SCADA. I'm not an English native speaker. My mother tongue is Korean, so please understand my poor English ability. This presentation introduces LNG plants' electric power distribution systems, but this knowledge can be applied not only LNG plant but also large-sized plants like oil gas refinery plants or chemical plants. This presentation consists of 4 chapters. The first, LNG plants power distribution system design. The second, typical power distribution concept at IEC 6180-51. The third, typical power distribution concept at IEEE standard 141. The last, KOGAS LNG terminals electric power distribution system. Before starting the main subject, I'll introduce a little information about KOGAS LNG terminals. If you are interested in LNG industry or oil gas industry, you might be heard KOGAS is so famous of its large LNG terminals. We have 4 tremendously big-sized LNG terminals in Korean Peninsula. As you can see this picture, Incheon LNG terminal is the biggest in terms of gas transmission capacity. Pyeongtaek LNG terminal is also the biggest with LNG storage capacity. It means these LNG terminals are using much electricity. To operate, monitor and control these kinds of big-sized electric power are very hard and difficult to electric engineers. Fortunately, thanks to our big-sized LNG terminals, I could have lots of experiences of various kinds of electric facility troubles and should have to study about our systems. So, I want to share this kind of knowledge and want to discuss with other plants electrical engineers about various kinds of their electric power systems and facilities. At the end of this presentation, I'll show you more detailed things about our LNG terminal's electric power system and capacity. This is a very interesting index about electricity. This shows us how important electricity is and the quality of electricity supply. Most people think the high quality of electricity is so important, and Lots of engineers also think the reliable and stable electric power is really important in plants. The concern about electricity and the role of electric power are vary in proportion to the country's competitiveness. I think how important workers think about electric power in their plant directly shows the company's culture and competitiveness. This is very interesting index. Okay, let's get to the main subject. Why is a power distribution system design important? I think power distribution system reflects the philosophy of the plant's operation as follows. It contains how to use and react to the plant's production lines or electric facilities when the power failure occurs or outage. Power distribution system also has the concept of repair and regular maintenance procedure. When the electric engineers design the system, they must consider safety of operators and its conveniences. Before designing the system, the electric engineers have to totally understand the plant facility's operating mechanism and their characteristics. According to the power distribution system, the location of substation should be designated in the yard, and the composition of main electrical equipment is also determined, such as GIS, switchgears, and cable routes. The most important thing is the cost should be changed in according to which distribution system is taken. As these reasons, to determine the power distribution system at a plant is so important. There are some useful and important international standards for plant electric power distribution system design. I think not a few electric engineers might know these already. When we consider these systems, usually we refer to these famous international standards. Those are IEC and IEEE. In IEC 61936-1, power installation exceeding 1 kV AC. That introduces the substation and electric facilities installation rules and concept. In IEC 61851-2005, communication networks and systems in substations. That introduces SCADA networks in industrial plants' electric power distribution systems. Actually, IEC 61851-2005 is not for plant power systems. It's for network systems for IED and SCADA, but it's Index A. They shows us the most popular electric power distribution systems among substations. IEC researched various kinds of plants and distribution systems for a couple of years. I think IEEE is the more popular international standard than IEC, just in terms of electric power distribution system design. At IEEE standard 141, recommended practice for electric power distribution for industrial plants, Chapter 2. They introduce a couple of kinds of electric power distributions. They give some information of its characteristics like IEC. At IEEE standard 493, design of reliable industrial and commercial power systems. They illustrated the fundamentals of reliability analysis applied to the planning and design of industrial electric power distribution systems. The systems between IEC and IEEE are very similar because, as they said, they researched many large plants in lots of countries. After searching, they classified various kinds of systems into a few popular and typical cases. So, these typical systems don't mean perfect systems and don't mean only one system in the plant's electricity. In IEEE, at the LNG plant's power distribution system design, the engineers have to consider as follows: the sum of electric loads, main transformer's capacity and quantity, voltage level, includes South Korea. I think in some of countries, the engineers must negotiate with the electric power companies about the primary incoming electricity's voltage level. Substation's location, cable route, earthquake proof, distribution types of among internal substations, control systems of electric power and circuit breakers, whether using synchronous transfer systems, high-speed bus transfer or not. Absolutely, safety and operating and maintenance convenience and economics. Actually, I didn't read and study all these standards as I mentioned above. If I need these standards for a reason, I frequently have been searching some part of these for reference. In IEC 61850-1 Index A, they suggest the most popular and typical 5 kinds distribution types. They distinguish distribution types D1, 2, 3, and transmission type T1, 2, and they said T-type is usually used in electric power plants' transmission substations. So, in this presentation, I'll talk just about D-types because I don't have information of electric power plants substations, and our company has just LNG plants and its substations. So, in this part, I'll show you IEC's D-type substations power distribution systems. D-type distribution systems are classified into 5 smaller units. So actually, D-type is classified into 6 kinds. Distribution type D1-1. As you can see in this picture, this is very simple. There is only one incoming line and has a few electric loads. So, this distribution system cannot choose a voltage level because it doesn't have a transformer. IEC said generally it has under 5 circuit breakers, but 6, 7, and more is okay, no problem. Under 5 means it is so simple, and usually this is very suitable for small plants. If the plant has a foul failure and it has no problem during the outage, in this case, this is so efficient in economic terms. The composition of electrical protective relays or IED are also simple, and it doesn't need expensive SCADA. I guess most LNG terminals in the world, just a few substations are using these distribution systems, but I'm not sure. Distribution type D1-2. This is a little complicated than D1-1. The difference with D1-1 is this has 2 incoming lines and has 1 transformer. So if the plant wants the different voltage level with the primary incoming, this system is suitable. In LNG plants, two incoming lines are necessary against one incoming line is fatal or repairing, or the electricity quality has some problem in one incoming line, such as frequency or alternating voltage. This system is also suitable at a small plant with a few electric loads, generally under 5 circuit breakers. If the two incoming lines have circuit breakers with a synchronous function, this is so useful, and HSBT is much better. In IEEE, they introduced this system with isolation switch at the two incoming lines, but I guess most plants might pretend the circuit breakers to isolate switches. Distribution type D2-1. D2 type is most popular and common system in large-sized plants. It has two incoming lines which originated from different sources and two transformers which have the same voltage level. Loop circuit is available when the conditions are met, such as a synchronous frequency angle, percent impedance of the two transformers, the direction of 3 pages. Generally, if the substation needs under 20 circuit breakers, this type is widely adopted. This is very stable and reliable electric power distribution system. In this system, operators or electric engineers can choose a primary supply individually. So, in terms of load balancing, this system is perfect. But the individual load has to have two circuit breakers. The switchgear loom must have a wide area, and the cost is rather expensive. If the circuit breakers have a synchronous transfer function, in this case there is no interruption to the load. SCADA is complicated and complex. Distribution type D2-2. D2-2 type is most popular and common system in large-sized plants. It has two incoming lines which originated from different sources and two transformers which have the same voltage level. In the same way with D2-1 type, if the two primary supply are originated from one source, it doesn't matter, it's okay. This is also a very stable and reliable electric power distribution system. Loop circuit is also available when the conditions are met. All coal gas plants are using this D2-2 type because of load balancing, and we don't use a loop circuit for preventing two incoming lines all fail simultaneously. In case of an electric fault of the tie breaker or a transformer or cables. If you want to use a loop circuit, in this case, you must consider and coordinate directional protective relays. This system with the synchronous function and HSBT is so effective for preventing power interruption. D3 type is a very complicated and complex system. The cost is most expensive. These types D3-1 and D3-2 are used in big-sized plants with over 20 circuit breakers. As you can see in this picture, these systems are extremely stable and reliable electric power distribution, perfect load balancing. These systems are mixed types of D2 distribution systems and spot networks. I surveyed some of LNG plants, but I couldn't find LNG plants which are using D3 type. But many of electric power supply companies' substations in Korea are using this D3 type distribution in their internal substations because in generating plants, power interruption, outage, electric fault make two serious problems with their power supply lines and generators. They are usually using 2 or 3 kinds of IEDs for preventing IEDs malfunction. So, SCADA is most complex and the engineers might get a lot of stress at work. From this page, we will see IEEE standard distribution systems. At IEEE standard 141.242, they introduce 7 sorts of industrial plant power distribution systems as follows. Simple radial system. This is similar to IEC D1-1 and 2. There's one primary supply and one transformer. So, the plant cannot avoid electric power shutdown when it needs repairing or maintenance. This is efficient in a small industrial plant. SCADA is so simple because of its simple composition and electric protection. Actually, I don't think expensive SCADA is necessary and suitable in this simple radial system as well as IEC D1-1. Expanded radial system. This is just to enlarge the simple radial system into internal its unit substations. This is also similar to IEC D1-1 and 2. This has one incoming line, but it has internal unit substations. This system can take the same voltage level with the same transformers or take different voltage levels with different transformation ratio transformers. In this case, SCADA is more complicated than simple radial system. This is efficient in a small industrial plant. The plant which has this distribution system cannot avoid the electric power shutdown when it needs repairing or maintenance of the incoming line. At the unit substation, if necessary, repairing is possible without the whole unit substation's shutdown. Primary selective system. This is similar to IEC D2-1. There's 2 incoming lines and 2 transformers. Each of main incoming line in the unit substations has 2 circuit breakers and it can choose primary supply or can use loop circuit. This is very stable and reliable electric power distribution system. This system with the synchronous function and HSBT is so effective for preventing power interruption. This is more complicated and complex SCADA than radial systems. The difference between IEC D2-1 and the primary selective system is the location of transformers. In IEC D2-1, the incoming line's voltage levels would be the same or not. If it is different, transform the different voltage into the same voltage. After then, supply the same voltage into the main internal loop. But as we can see this primary selective system, the 2 primary incoming's voltage level must be same for using transformers simultaneously. Primary loop system. This is similar to IEC D1-2. The only difference is that primary loop system has a few unit substations in their plants. It has the same voltage level with two incoming lines. Even though one primary supply has problem, the whole substation has no problem, without just a short dip or sag when the main circuit breaker is opening or closing. Absolutely, the plant can choose separating lines or loop circuit. In IEEE, they said that this system depends on the trained operators whether isolate the incoming line or loop the line. It means, as I said earlier, the operation engineer and electric engineer must consider directional electric protective relays coordination. IEEE, they introduced closed loop system and open loop system. If two incoming lines are originated from different buses, we must consider short circuit capacity. In this presentation, both IEC system and IEEE systems, if we want to use loop system, the incoming cable and transformer must have capacity which can supply the whole electric loads in its substation. And the relay coordination setting value also should be considered the whole load's short circuit capacity. Closed loop system improves reliability and service continuity. At the open loop system, it could have a temporary loss of service when one line is fault, but we can recover it immediately. To use open loop or closed loop, it totally depends on the company's operating philosophy and concept against how to react when the power outage occurs and it's no problem at a short period of breakout. Secondary selective system. This is very similar to IEC D2-2. It has two incoming lines which originated from different sources and two transformers which have the same voltage level. I think this could be more stable and reliable than radial system or loop system when it has a synchronous function and HSBT. As you understand, loop circuit is available when the conditions are met. The incoming lines cable, circuit breaker, and transformer have to carry the total load for the loop circuit. This is a secondary spot network. This is the most reliable power supply system in terms of loads. IEEE said this is recommended as low voltage applications with a high load density. But as we saw in IEC, many plants are using this at a medium and high voltage. In this system, the electric engineers should consider load shedding in case of a simultaneous failure of primary supplies. I understand there's excellent reliable electric devices for load shedding already. For more efficient and effective, the incoming lines originated from different buses are much better than the same buses. Ring bus. This is similar to IEC D2-2, but I think this is mixed distribution type between secondary selective system and loop system. SCADA is very complicated and complex, with many tight circuit breakers. It's possible to consist of various kinds of loops. When electric engineers are trying to design plants' electric power distribution systems, Mostly, they are considering the systems with these IEC and IEEE samples. There's no perfect system for supplying electricity. We always have to think pros and cons for which is more appropriate in our plant. I think the distribution system is totally depends on the company's operating facilities philosophy. And the important thing is the electric engineers have to understand his own distribution system's pros and cons. Okay, finally, in this page I'll introduce our plant's electric power distribution systems. At the earlier page I showed you coal gas for LNG terminals, and I also said we are using IEC D2-2 or IEEE secondary selective system. In our plants, we are using two incoming lines simultaneously, which originated from different buses in different substations. We separate and distinguish the two lines as A bus and B bus. Like this picture, normally we don't use type breakers, just sometimes for repairing or maintenance or get some troubles. In this case, we only use one line at a substation. This means coal gas is a state-run company and the only company which supplies natural gas in Korea. Most of all, we are focusing stable and reliable natural gas supply in any case. So, we don't use loop system between the two incoming lines against all lines failure or open circuit breakers in case of using loop systems. As I said, this is not the perfect system, but we choose this and we think this is more suitable for our LNG plants. A few years ago, we installed HSBT at all LNG terminals. This function is really useful and has extremely high reliability. I strongly recommend this device for LNG plants. Okay, this is coal gas LNG terminal's electric power capacity. Except Tongyeong LNG terminal, we are using two primary supplies which are originated with different buses. In coal gas LNG terminals, in terms of IEC and IEEE classification, we are using D2-2 or secondary selective system as main system. And we also have D2-1 or primary selective system and D1-1 or simple radial system partially in internal unit substations. Okay, these are all that I prepared for my audience. Once more, I think there's no perfect system for supplying electricity. We always have to think pros and cons for which is more suitable in our plant. Thank you for seeing this presentation, and if you have a question, don't hesitate and please send me email. As I said, I made this for discussing and sharing ideas each other. Okay, thank you. Be engineer.